we are going to start integration chapter. This is chapter 11. It starts on listing and then using standard results. So we are going to list them by thinking about results from last year, year 1, but also by applying the inverse of differentiation, and we've done lots of differentiating already this year. So if I put on the left hand side the function f of x, and we're going to integrate it to the integral of that function, we're going to write the answer to that. I'm not going to put plus c with every answer, I'll just do it in a couple. So definitely know at least one very easy one. So x to the power of n from last year, you add 1 to the power, you divide by that new power. I'll put plus c this one. Obviously you could have written it as 1 over n plus 1, and then x to the power of n plus 1. Okay, that's another way of writing it. Now, this next one, we're going to look at e to the power of x. Well, you know from last year and this year as well, e to the power of x differentiates to e to the power of x. So that means the e to the power of x will integrate back to itself. Okay. Now, if you had e to the power of kx, remember this is a quick chain rule that you apply. You will have k e to the power of kx. So this integrates to this function. So if I wanted to have e to the power of kx over here, then clearly I'll need to divide through by k. So the function that was differentiated must have been 1 over k e to the power of kx. That tells me that e to the power of kx must integrate to 1 over k e to the power of kx. Okay, in differentiation chapter you've learned that sine differentiates to cos, cos differentiates to minus sine, and you can just close the loop. That goes to minus cos, and then carry on. So clockwise you will differentiate. Now what we can do, we can reverse that process and go in anti-clockwise direction, and we're going to integrate and get our results for integrating sine and cos. So if I follow the loop the other way around, so if I do go this way, you could see this pink is integration. That tells me that sine x integrates to minus cos x. Then you carry on, cos x integrates to minus sine to cos, and cos integrates to sine. So cos x goes to positive sine x, while sine x goes to negative cos x, because it's reversing differentiation. Now we also learned that tan x differentiates to sec squared. So obviously sec squared will be one of the standard results that integrates to tan x. And obviously if you remember, you had cosec squared x, well, you had minus cosec squared being what cot differentiates to. So makes sense if you reverse the steps and move the minus across. Cosec squared will go to minus cot x, obviously plus c. So another two results that you've learned in differentiation chapter is what will sec x differentiates to. That goes to sec x tan x. And then you've got cosec x, that differentiates to minus cosec x cot x. So then if you reverse it, you will get sec x being one of the standard results. That will go to sec, and then cosec cot x cot x, that will go to minus cosec x. All of these plus c. I said I won't write it, but I'm going to. There you go. So really the question would be find the integral of this function, this function, this function. It would be written like this. Or you could say this function integrates to the left hand side. There you go. So these are our standard results, which you need to remember. Some of them are listed in the formula booklet, so you can find them under differentiation if you know how to reverse the process, and some of them will be under integration. So you've got these 4 at the end will be listed in the formula booklet. So let's move on to example 1 of this chapter. You've got to find the integral of 2 cos x plus x. Oh, right, I've just realized I've missed one out that we need to list for sure. Okay, so there's one more to be added. This is 1 over x. The integral of 1 over x is ln x. Example 1, you've got to integrate 2 cos x plus 3 over x minus root x. So cos x goes to sine x, so 2 of them will go to 2 sine. 3 over x is 3 lots of 1 over x, so that will go to 3 ln modulus of x. And then x to the power, square root of x is x to the power of a half. So here we're going to add 1 to the power, divide by that power. So it's x to the power of 3 over 2 divided by 3 over 2 and plus c. So you've got 2 sine x plus 3 ln x minus 2/3 x to the power of 3 over 2 plus c. Part B, you've got integral of cos x over sine squared x minus 2e to the power of x. So 2e to the power of x, that will be easy. But what do we do here? Well, you've got to be able to use one of the standard results. And here you just need to spot that this is the result of multiplying cos x over sine x by 1 over sine x. And this is cosec and this is cot. So we are going to be integrating, if I switch them around, cosec x and cot x, and this is one of the standard results. I don't like integrating parts first. If I know that that integrates to 2ex, I'll do that. I just like to do everything once everything is prepared for integration. So we've prepared it for integration. Cosec x cot x goes to minus cosec x, and then actually it will stay the same, minus 2e to the power of x plus c. Okay, in example 2, we've got to find the value of a. A is a positive constant. If the integral of 2x plus 1 over x defined between the limits a and 3a is equal to ln 12. So we're going to integrate first of all 2x plus 1 over x between the limits a and 3a. This is going to be prepared for integration. We're going to split, so you will have 2x over x and then 1 over x. So this is the integral of 2 plus 1 over x. Forgot the dx there. Let's just put it down. So 2 goes to 2x and 1 over x goes to ln of x modulus of between a and 3a. Let's carry over here. So we're subbing the limits. You're going to have 2 times 3a plus ln 3a. I don't need modulus symbols now because a is positive, minus 2a plus ln a. So this is going to be 6a minus 2a, which is 4a, plus ln 3a minus ln a. Okay, we are told that this here is equal to ln 12. So we're going to try and find what a is. So it's 4a. Let's put all ln's on one side and we combine them. So it's ln 12. And then if we can actually, yeah, let's write it like that first. Combining these, we are going to obtain ln. When you've got pluses, these will be multiplied. When you've got a minus in front of ln, that's divided. So you've got 12 times a goes in the numerator and divided by 3a. So a cancels, 3 cancels with that, and you've got 4a is equal to ln 4. So a is equal to a quarter of ln 4. However, here you could rewrite ln 4, just to show you in case you are asked to express it in terms of ln 2. You write the square numbers 2 squared and you bring the 2 to the front. So it's 2 ln 2. So if you replace it, your a actually is a quarter times 2 ln 2, and that is a half of ln 2. So you can have a go at exercise 11a.